Welcome to this web lecture on location covering problems. A location covering problem is actually a facility location problem, but using the specificities of, for example, an ambulance location. And this is also what we're going to look at throughout this web lecture. So the city of Eindhoven considers building one or multiple new ambulance stations. And the question is, where should they place the new ambulance stations? They obviously should consider cost. So it should be cost efficient where they're placing the ambulance station or stations. But at the same time, it should also be very close to patients and it should be fair. If we're looking into the proximity to patients, there's actually even rules and regulations that specify that. For instance, within the Netherlands, each patient shall be able to reach an emergency room, so a hospital, within 45 minutes, which means that the ambulance must drive from the ambulance station to the patient, pick up the patient, do first aid treatment, and then continue to the hospital. In most other countries, usually the distance from the ambulance station to the patient is regulated, which in Germany shall be 12 minutes or less, or in Australia should be 85% of all patients within 15 minutes. So let's look into how we're modeling this. So we're going to look into the recipe for formulations, which means we're identifying sets and parameters, we're introducing decision variables, and we're formulating constraints and the objective function. So first and foremost, let's look into the sets. So we obviously have a set of locations which is comprised of candidate locations for ambulances and patient locations. A candidate location is a location where I can place something. So it's a discretization of the continuous space. And in this case, in the case of ambulance locations, it might, for example, make sense to use hospitals as candidate locations. The patient locations is a very big set, but it's relatively obvious what it is. What we still need is one additional set. So let's just say we have a patient up here and we have quite a few candidate locations for ambulances, but bad luck for this patient, we're actually opening the ambulance station in the south and the one in the west, and neither of these stations allows this patient to reach this hospital in 45 minutes. So we need additionally a set that tells us this patient can be reached by this ambulance and still be transported to the hospital on time. And this is where we use the auxiliary ambulance reachability set, AP. So AP specifies that for patient P, these ambulances are candidate locations. The one in the south and the one in the west are too far away, so they're not within this set. What I would like you to think about is if you can think about other approaches for modeling reachability between ambulance and patient. This next thing that we need is parameters and decision variables. In this case, we only have one decision variable, which is opening an ambulance station, like this. But then, of course, we also have costs associated with opening a station. So we're minimizing yi times fi in the end. So we also need these opening costs. Then we're looking into constraints. So the fairly obvious constraint is, of course, the domain. What is a little bit more tricky to think about is this reach all locations within the time limit. And what we're saying here is that at least one of the locations that are reachable from a patient has to be open. So, for instance, if we only open the one in the south and the one in the west, then here the left-hand side would be 0 for the patient in the northeast of the city. And then this would be infeasible. So we're doing this for each patient, and we're always considering the patient's specific set of candidate locations. And I would say the minimizing the costs, that is once again fairly obvious. What I would like you to take away from this web lecture on the location covering problem using ambulance stations is first of all the basic formulation. Secondly, I would like you to remember that we can use self-defined sets in mathematical modeling, and we just have to write it down. What I would like you to think about is this reachability topic. So there's multiple different formulations how we can model reachability. And what we're going to look into in our next lecture is fairness. Thank you very much.